So everyone, please turn to page 37. Okay, page 37 is talking about a pizza, right? A slice of a sector. We call that a sector, right? Or you can look at it as a slice of pizza. And then we're gonna find different parts of the pizza, right? So given a sector of a circle, right? The shaded part is called a sector of circle. We have radius, and then the length, L. L is the arc length, right? You can underline that, arc. And theta is the angular measure in radians. So this is very important, okay? It has to be in radian. And then we are going to find the formulas for finding the arc length, okay? And also finding the area of the pizza shape, okay? So before giving to you, we're gonna go through how the formula is derived. So here we'll prove the formula for area and arc length, okay? So the way to do this is very easy. You just compare the ratio of the sector, okay? Let's write that down, sector to the whole circle, okay? So sector of a circle to the whole circle, right? And then write out the proportion, right? In grade 9 or grade 8, I think you learn about ratio and proportion, right? So sector area, right, which means this part, everything shaded inside, that's called the A. We put that on the top, right? A stands for the area of the sector. And then whole circle, how do we find the area of the whole circle? What's the formula, William?
The what?
The area of the whole circle, do you know the formula?
Pi r squared.
Pi r squared. Okay, so remember here, the top is for the sector. The bottom is for the whole circle, right? And then let's talk about the length, right? Outside length. We call that the arc length. So for the sector, the arc length is L, right? So I'll put L there. And then for the whole circle, what is the formula for the arc length? Well, actually the outside, what do we call the outside? Tiana, the outside distance around the whole circle. What do we call that? Tiana, are you there?
Circumference.
Yeah, and do you remember the formula for circumference? Do you remember, Tiana?
Is it 2 pi r?
Yeah, very good. Okay, you can write 2 pi r or pi times diameter, right? Since we have radius, so we are going to use 2 pi r, okay? And then the angle, let's talk about the angle, right? There are three things here. The next variable is the theta. Theta is talking about the angle at the center, right? So that will be theta, right, for the sector. So everything on the sector is unknown, right? But we have the formula for the whole circle. And then what's the central angle for the whole circle? Eric?
360.
Yeah, and what would that be in radian?
2 pi.
Yes, very good, okay? So remember pi is 180, right? And then 2 pi will be 360. So everything underneath in the denominator is talking about the complete circle, right? So this part is talking about angle, right? So left side is the ratio of area. Middle is ratio of length. And then right side is the ratio of the angles. Okay, and they should be equal, right? Because it's part of the circle. So now what we are going to do is just pick two of them and then isolate the thing that we want, okay? So I'm going to pick the first one and the last one, area and the angle ones, okay? So I'm going to split this, okay? And then write it here. Okay, and then from here, I would like you to isolate the area. Okay, so please copy this down, right? The proportion over here, and then isolate the area. I want to find a formula for the area of the sector. Okay, once you isolate the area, please raise your hand. Okay. And if you see anything that can be reduced, right, or canceled out, right, you can do that too. Right, so Ray, what do you have when you isolate A?
I'm not sure if it's correct, but A equals theta pi r squared over 2 pi.
Yeah, so basically you just do the cross multiply, right? So this one multiplies over to the other side. So is there anything I can reduce or cancel out, Donna?
Pi.
Pi I
So
can,
then,
right?
yeah.
Yeah.
And then it's theta
Mhm.
r squared over 2.
Yes, very good. Okay, so theta r squared over 2. So remember the theta has to be in radian, okay? And it's the angle in the center. So if you want to find the area of a slice of pizza, right, all you need to know is the angle and the radius, then you can find it, okay? So let's fill that in. That's our first formula, okay? So that will go into the box on the top. A equal theta r squared over 2. Okay, now the next one we're going to isolate is between the last two, right? The length and the angle. We're gonna put them together. So let's draw a line here. L over 2 pi r equals to theta over 2 pi. So same thing, we are going to isolate the L. Okay, L represent the arc length, right? The outside distance of the pizza. Okay, so please raise your hand once you isolate the L. Okay, Cindy, what do you have?
Theta r.
L equal theta r, yeah, okay. So if you cross multiply over, you get 2 pi r theta. And then this time we also canceled out the 2 pi, right? So we get theta r. So that will be our second formula, right? L, arc length is theta times r. So you just need to know the angle and the radius. Multiply together, that will give you the arc length, okay? Now there's another box, right? Which is derived from the combination of the first two, okay? So because if you look at the formula, theta r is same as, like, it also appear in the area, right? So I can rewrite the second one as differently, right? So for example, this one, okay, so I'm going back down here. I can write it as theta r times r over 2, right? Because r squared is r times r. And then the theta r, that portion, I can replace it with L. Make sense? Right? Because from the second formula that we derived, L is theta r, right? So depending on what's given, then you will choose different ones, right? So we have the next formula is A equals to L r over 2. Okay, so if we are given the arc length, then we use the second one, right? If we are given the angle, then we use the first one. And then for arc length, you only have the one formula. Okay, area, you have two choices depending on what's given. Okay, do we have any questions here? Okay, so these formula you have to memorize because usually they are not given in the on the test. Okay, some formula which are longer, then they will give it to you. Like sine law, cosine law, they usually give it to you, right? But these ones they don't give it to you. Okay, so let's try a few questions first. So then you get to practice subbing into formula, and then I'll ask you to memorize it out. Okay. All right, so let's look at question 5. Determine the angle at the center of the circle, right? So which variable are we finding? Trudy, what are we finding here?
The angle?
Yes, and what's the variable?
Mm,
We have the L, we have the A, we have the theta, we have the R. Which one?
we have the L.
Angle at the center, what's the variable for that?
Angle theta.
Yes, okay, so first you have your target locked on, okay? You are looking for data, and then you look at what's given, right? We know the radius is 6, arc length is 8. So you pick your own formula, right? Think about which one should be applied here. Okay, once you get the answer, please raise your hand. You have 3 choices, okay? You want to find data, so you look at which one has data inside. And then you look at what's given and think about which one we can plug in, right, to find the data. Okay, please raise your hand if you get the answer. And let's give a name for, give a number for the formula, okay, will be easier. Formula 1, 2, 3, okay, 3 formula. Does anyone have questions how to do A?
Are we supposed to choose one of the three?
Yeah, choose one of the 3 to solve.
Oh, okay.
Sometimes you need 2 of them, okay? But then for this question, you just need 1, okay? This one is not too difficult. Is there anyone having trouble choosing the formula, like doesn't know which one to choose, which one to use? First, you look at the three formula, which one has data, right? And then after that, you look at what's given. We have radius, we have length. So which one is the one? Please raise your hand if you get the answer. Okay, William, which one did you choose?
The arc length one.
Okay, so number one, right?
Yeah.
Okay. And then Tiana, what do you have? What's your answer?
I have 1.33.
1.33. So 3 repeating.
Yeah.
Yeah, and what did you do to get that? Can you tell me?
I don't know.
Huh?
I don't know.
Use the same formula?
Yes.
Yeah, okay. And what did you put inside the L?
8.0.
8.0. So I can just write 8, right? So 8
Yeah.
equals to data times
6.
6. And then you isolate data. How do you do that?
Divide
By,
6.
yeah, okay. So data
Okay.
is 8/6, right? You could leave your answer in fraction, right? That will be like 4/3, or you leave it in decimal. That's fine, okay?
Oh.
Yeah, sometimes you think, oh, it's too easy to be true, right? But that's really easy for the first one, right? Okay, and then this angle is in radian. Okay, everything here has to be in radian for it to work, and then so you don't need to put a little circle, right? So the next question, we'll try that. Okay, similar. So the same thing, right? We have radius, we have arc length, okay? So it's using the same formula, so I'm not going through the steps here. So once you get the answer, please raise your hand. So the only thinking part required is just to choose the formula, right? And you only have 3 choices. And then the rest of it is just plugging in.
Do we do the next one?
Yeah, if you are sure question B is okay, right? Then you move on. We are gonna do question 6. Please raise your hand if you finished 5B. Okay, Trudy, what's your answer?
I got 9/5.
9/5. Yeah, very good. Okay, so you take the length, divide by radius. Okay, question 6 is finding the sector area, right? And the variable for that, right, for sure is A. Okay, so once you're, you know what you're finding, right? You have 2 choices here. So think about which one we should choose. Okay, so same thing, I'll let you try it. This is not too difficult, okay? Usually I will give you some hint or discuss about it. But I think this one is just choosing the formula and plug the number in. You can handle it.
Does 1.3 have a degree on it?
No, it doesn't. So 1.3 is a radian.
Oh,
Okay, so if you get the answer for A, please raise your hand. Okay, Donna, can you tell me which formula did you choose? Number 1, 2, or 3?
number 2.
Number 2. Okay, very good. We have angle, right, and the radius. So it'll be theta r squared over 2. Okay, and all we need to do is just plug the number into theta, right? 1.3 times 17 squared over 2. And can use your calculator. Okay, William, what do you have for your final answer?
187.85.
Okay, Eric, what about you? Eric, do you have the same?
Oh, yeah.
Okay, and what do you think the unit is? What unit?
Centimeters.
Just centimeter only?
Centimeter squared.
Yeah, okay, it's an area, right? So you have to use centimeter squared. So remember, you need to put units. For angle, right, we didn't need to put it because in radian, right? But if it's in degree, you need to put a little circle, right? Okay, let's look at question B now. Okay, so same thing, I'll let you try it. And please raise your hand if you find the final answer, right? We are still looking for area, but we are given different things, okay? This one is a little bit more work than the other ones. Does anybody need a hint?
Do we need to use 2?
Yeah, this one you will need to use 2. That's correct. Right, because if you look at the area formula, right? One formula needs angle and radius, but the question only has angle, right? Doesn't have radius. And then the other formula needs arc length and radius. And this one has arc length and also doesn't have radius, right? So we're missing radius here. So that's why we need to think about how we can find radius. Need to figure out the radius before we can find area. Okay, that's the plan. So there are 2 steps involved here, okay? Still manageable, right? It's not like Mountain Everest, right? Only 2 formulas needed. So far, only one person raising the hand. Who's having trouble here? Anyone?
I don't know which formulas to use.
Okay, so our first part is to find radius, right? Yeah, Eric?
Yeah.
Wait,
Yeah.
we need to
Mhm.
we need to switch 60° to radian.
Yes, very good. Okay, let's do that first, okay? Because the angle, to use the angle, we have to put it in radian. Okay, so let's circle that. Right, 60 degree, is that special? Tiana, is 60 degrees special?
Yes.
Okay, and what is that in radian?
Pi/3.
Yeah, very good. Okay, it's 1/3 of the 180 degree, right? So we have that now figured out, right? And then you look at the 2 formula for area. They both need radius, but because the question doesn't give you radius, so we need to look at another formula. So Eric, what other formula do we need to look at?
Um, can we use number 3?
Number 3. Well, number 3 is you need to find area, right? You need to have area, length, and radius, right?
Yeah.
Okay, so you look at the question. Area, we don't know.
Yeah.
Arc length, we know, right? We know the arc length, but we also don't know radius. So if you have 2 unknown, we cannot find it. Make
Oh,
sense? Right?
Okay.
The whole formula, you can only have 1 missing, then we can solve. So which formula has only 1 thing missing?
Data over 2 pi.
Which one?
The data over 2 pi.
Theta over 2 pi, where's that?
Or, I don't know.
No, there are 3 formula. Look at the 3 formula on the
Oh,
you
uh,
choose from there.
number 2.
Number 2, what
Right.
variable do you see there?
Area,
Mhm,
data,
mhm.
and radius.
Okay, do you have 2 of them?
2. What?
Do you know the area?
No.
Do you know the data?
Yes.
Do you know the radius?
No.
Okay, so how many things are missing?
2.
then can we use it?
No.
No, right? So we cannot use that one either, right? So what's
Yeah.
another choice?
1.
Yes, okay. So we have to choose number 1, right?
Okay.
Because all the 3 formula, they all come from sector. So you can use them as like whenever needed, okay? So we'll choose the first one. So what do we know inside this formula, Eric?
You know the length and data.
Yeah, so we can use it to find,
Radius.
yeah, okay, so we plug it in, right? So 20 is pi over 3 times radius. So you can use that to find radius. Once you find the radius, you continue to do step 2, right? Let's write down step. Step 1, right? Step 2. Then once you have the radius, you could use any formula, right? Because you have more than you need, right? Okay, so please raise your hand if you get the final answer for area. So there are 2 tricky parts here, right? First thing is you need 2 formula, right? Second thing is the angle has to be in radian before you plug it in. Is there anyone still having trouble here? Like doesn't know how to continue? Step 1, step 2. Let me know, okay? I can explain more. So when you are trying to use the formula, right? Always think about, ask yourself questions, right? Do I have enough information, right? Because if you want to use it, you can only have one unknown in the formula, right? If you have 2 unknowns, you cannot apply, right? Please raise your hand if you got the answer. Okay, William, you finished long time ago, right? What's your final answer?
190.
190, so cm squared, right?
Yeah.
Okay. Donna, what's yours?
191.
91. Okay. Oh, a little bit bigger. Okay, that's interesting. Okay. Ray?
How many decimals should I round it to?
2?
Oh, dang it.
So 190.99.
Oh, okay. Oh, that's why you get a 191. Okay, that's all right. So I guess you all agree with that. Let's check the radius. Okay, let's see if we keep everything in pi and what answer you will get. Okay, so Cindy, what do you have for radius?
60 over pi.
Yeah, okay, so let's keep the pi there, okay? Instead of using 3.14, we'll keep it in pi. And then area, which formula did you choose for step 2, Trudy?
I chose the formula hold on. Wait.
You can,
Formula number 3.
so
I use that one.
L, is it the one with the L?
Yeah.
Okay, so LR over 2, right? So can you tell me what you plug in? What number did you plug in?
I plugged in 20 times R, the 60 over pi.
Yeah.
All over 2.
Yeah, all over 2, I can write it as divide by 2, right? Okay, and then let's simplify this. So that will become the top, right? 20, you can think of it as 20 over 1. So that will be 1200 over pi times a half. So 600 over pi. Right, so it will be better if you know how to leave answering exact, okay? Rather than always just decimals, right? Plug into calculator, because sometimes multiple choice, their answers are in exact answers, okay? Instead of approximate. So these numbers are okay, right? Depending on how many decimal you keep. Okay, any questions? Okay, so please write down the exact answers, okay? All right, so if no questions, that finished the introduction, okay, for the angle, right? We can use the angle to find different things, right? To find arc lengths, to find area, right? And then we also went over some terms, right? Reference angle, principal angles, right? And then changing between 2 units, degree and radian. So now we're gonna combine everything there, and then add it to the next section, and then we have other kinds of questions, okay, involving those things. So here we are going to talk about 6-trig ratio. Okay, I think during last class we mentioned that in grade 10 you learned about SOHCAHTOA, right? So today we're gonna talk about where the SOHCAHTOA come from, right? Why is it called sine? Why is it called cosine? Right? How come they sound so close, right? Sine, cosine. And then we will be adding 3 more names, okay? So if you look at the terms here, number 1 is sine. Number 2 is called secant, okay? Number 3 is tangent. Tangent you already know, right? Number 4, cosine. Number 5, cosecant. Number 6, cotangent. So these names are pretty new. So I would like everybody to turn on your mic. Okay, we'll say these names together. Okay. Just to help you remember them more easily. Okay, please turn on your mic. All right, so let's say together sine, cosine. Everybody?
Sine,
Cosine.
cosine.
Yeah, they come in pair. Okay, one more time. Sine, cosine.
Sine, cosine.
Cosine.
So that's number 1 and 4. Next one, secant, cosecant.
Secant,
cosecant.
cosecant.
Yeah, one more time. Secant, cosecant.
Secant,
Secant,
cosecant.
Okay, next one, tangent, cotangent.
Tangent,
Tangent,
cotangent.
cotangent.
Tangent,
Yes. Okay, again, tangent, cotangent.
Tangent,
Tangent,
cotangent.
cotangent.
Yeah. Okay, so they all carry a cot, right? So we're gonna talk about why we have a cot in front. Okay, you can turn off your mic now. So let's start with the first identity, right? Identity means a rule, okay? The rule is called a complementary. Does anybody know what complementary angle means? What does that mean? What is complementary angle? They are angles that what? Anyone? Complementary angle, supplementary angle, ring any bell? What's complementary angle? Cindy, do you know?
No.
Okay, Donna? Donna, do you know what's complementary angles?
Something that are
Mm-hmm.
the same,
The,
different.
the same, different? What do you mean? Which one? The same or different? Not sure?
That are different.
That are different. Okay. We need more detail. Anybody else want to add to that?
Wait, I looked it up.
Oh, you are Googling, huh?
Combining in such a way as to enhance or emphasize the qualities of each other or another.
But you need to talk in a mathematical sense, right? In the context of math. What's complementary angle? Irae, do you know?
They add up to 90 degrees.
Yes, okay. In terms of angles, it has to add up together. So your definition is more of a daily life, right? When you see something complementary on the newspaper, right? What it means. We want to explain it in math, right? So angles that add up to pi over 2. Okay, I'm gonna use radian now, right? So you guys have to get used to it, right? Add up to 90 degree, which is pi over 2. So if you look at this picture, right? We have 90 degree here, right? So that means angle A and B, they should also add up to pi over 2 as well, right? Because the whole thing should add up to pi, right? The angles is add up to 180, all right? So we have A plus B equals to pi over 2. Any question about this? Right? They both add up to 90 degree. So that means A is the same as pi over 2, take away B, right? Or B is pi over 2, take away A, right? From there, we can figure that out, right? So they are complementary to each other. A is complementary to B, B is complementary to A. Okay, so if we now agree on that, we're gonna look at the first ratio. Okay, the first ratio is called a sine ratio. Sine ratio, everybody already remember, right? Sine comes from the, it's a ratio representing the SOH, right? SOH. So SOH represents which side over which side? Truly?
It's opposite over adjacent.
Okay, so if you look at the picture now, can you tell me which one is the opposite, which one is adjacent?
The opposite is y,
Yeah.
and opposite over hypotenuse, right?
Okay.
And the hypotenuse is r.
All right. Okay. So let me write down the. Thank you. Okay. So opposite over hypotenuse. I'll write down the name first. Opposite over hypotenuse, which is y over r. Okay. Now we are going to move on, right? So this is from something you already know before. So we are just picking two sides and then call that a sine ratio, okay? So if I keep the same sides, y and r, okay, and I'm writing it backwards, which is the same as sine A, right? And from the complementary angle part, A, I can write it as pi over 2 minus B, correct? Right? So I can rewrite the A as pi over 2 minus B. Right? So far, the first line is same as the second line. Make sense? And then I can write it as in sentence. Angle A is the same as complementary of B. Right? Complementary of B is A. Complementary of A is B. Right? That's the meaning, like, because they add up to 90 degrees. So we have complementary of B. Okay? And then to simplify this part, what they did is they picked the first two letters. Complementary, they pick co of B, right? Complementary of B, and then combine with the sign at the front. And then together they call that cosine of B. Okay? So cosine actually means complementary of sine, but you are looking at angle B. Right? This should be pretty new to everyone, right? So that's where the word cosine come from. Okay, co means complementary, but it's looking from different angle though, right? You started with sine A, but then cosine comes from looking from B, right? And then to simplify the writing, they pick the three letter, okay, COS, and then write it as cosine B. So if you trace back every line, right, equal, all the way back, sine A is y over r. Cosine B is also y over r. Okay, so let's look at the sides. If you look from angle B, okay, everybody please look at angle B in the picture. If angle B cosine is y over r, if you look from B, what's the name of this y? The side, the name of the side for y. What I mean is it opposite side, adjacent side, or hypotenuse? Okay, what is y? Eric?
Adjacent. Oh
Yeah.
wait, I'm not Eric. I'm sorry.
Okay.
I'm William.
Hello, hello.
Here.
Yeah, well, William, you can continue answer. You got it. Okay. So y is called the which side?
Oh what?
You said y is the which side?
Adjacent for B, right? Looking from B.
Yeah, looking from B.
Okay.
And how about r?
Hypotenuse.
Hypotenuse. Okay, so the name changed, right? So for sine A, it's opposite over hypotenuse. Cosine B will be adjacent over hypotenuse. Okay, so here we have a rule. That's why they ask you to memorize as CA, right? So katoa, ka is CAH. So that's where adjacent over hypotenuse come from, because you're looking from a different angle. Okay, so we're gonna go through each one by one. Okay, so you will know where the names come from and what their sides are. Right? Let's do the tangent one, because tangent we are familiar, right? So let's look at tangent first. Tangent we learned that is TOA, right? So TOA, it represents which side over which side? Tiana?
Opposite over adjacent.
Yep, opposite over adjacent. Okay, so this time I'm gonna let you guys to help me go through the steps, okay? So, Ray, opposite over adjacent looking from angle A. What over what?
Y over X.
Opposite over adjacent, yep. Opposite is Y, adjacent is X. Okay, so I'm gonna do the same thing, okay, step by step. So I'll start with Y over X, which is tangent A. Okay, so everybody can write this down, which will equal to tangent of what? What should go inside the second bracket? Cindy?
Pi over 2 minus b.
Yeah, very good. Okay, so 90-degree take away angle B will be angle A, right? So first line, same as second line. And then the next line, we're going to write it in sentence, right? So it'll be tangent of, okay, what do we put inside the bracket now? Eric? Eric, yeah.
Yeah.
What do we put inside now?
Complementary of B.
Yep, very good. Complementary of B, and then we are going to, same thing, pick the letter co, combine with 10, right? So what do we put outside the bracket? Ray?
Cotan.
Yeah, very good. So co-10, right? So it'll be complementary of tangent, but then it will be for looking from angle B, right? So that will be COT. We pick the first three letters. Okay, cotangent of B. Now if we trace back, right, looking from angle B, and it's for y over x. Okay, so please look at the picture now, looking from angle B, y over x. Which side over which side now? Trudy?
Sorry, what?
If I look from angle B, okay, look at the picture on the top.
Mm-hmm.
Okay, I want to do y over x.
Mm.
What's the name of the side? Is it opposite, adjacent, hypotenuse? What is y over x?
Tangent.
Yeah,
Yes.
tangent is looking from angle A, right?
Mm.
Right now we are looking from angle B. If you look from angle B, what's the name of the y? Would you call that hypotenuse, opposite, adjacent?
Adjacent.
Yeah. What about x?
Opposite.
Yes. So y over x will be what over what? Which side over which side?
Adjacent over opposite.
Yes. Okay. So that will be the definition for cotangent. Okay. So right now what we're trying to figure out is the meaning of each ratio, right? So cotoa you already know. But cotangent is the new one here, right? Cotangent is the flip over, right? You can call that reciprocal of the tangent. You flip upside down. Tangent is opposite adjacent, right? Cotangent is adjacent over opposite, right? You flip around. Okay, so far we have y over r, right? We also have y over x. Okay, what else is missing? Right, because we still have a pair in the middle, right? What other combination we haven't done yet?
X over R.
Yes, very good. Okay, so the next one we're gonna do is the x over r. And we'll start by looking at angle A. Looking from angle A. Okay, let me erase the colors. Okay, so, okay, looking from angle A, x over r. Which side over which side is that? X over r. Cindy? X over r.
Adjacent over hypotenuse.
Yeah, adjacent over hypotenuse. Okay, so this is x over r. So we are going to go through the same thing, x over r to start, which is secant, right? Secant of A. And what is the next line? Tiana?
Secant of pi over 2 minus b.
Yeah, very good. Okay, Trudy, next line.
Mm.
What is the next line?
Sec complementary of B.
Secant, it's called secant.
Okay.
Secant complementary of B. Okay. And then we are going to pick the letters out, call, and then seek, right? Seek is called secant, right? Don't say sick. People will think it's sick, right? Right, so it'll be cosecant. Okay, that's the full name of B. Now for this one, we cannot pick the three letter, right? Because you will get confused with cosine, right? You cannot pick COS. So instead, they pick CSC. Okay, that will be the abbreviation for cosecant. So be cosecant of B. And that is also equal to x over r. Right? But then we have to look from angle B now. So please look at the picture again. This time we're going to look at angle B and x over r. So which side over which side now? William?
It is opposite over hypotenuse.
Yes. Okay. So that will take care of all the combination that you could have. Okay. Right. If you have three sides, all the ways you can pair them up. You can have opposite over hypotenuse, right? Let's box the 6 boxes here, right? Sine is opposite over hypotenuse, right? And then you have adjacent over hypotenuse, and then adjacent. Hold on a sec. I think we mix up something here, okay? Because adjacent over hypotenuse, we've done it, right? We shouldn't be doing x over r. So we made a mistake here. Is r over x, okay? We need to flip this upside down, okay? So take out your eraser, okay? Just little fix here. Hypotenuse over adjacent, right? Because we already have adjacent over hypotenuse for cosine, right? We want a new one. So it'll be r over x, okay? So that will need to fix here. R over x, the rest are the same, okay? Just the name underneath will be different, will be upside down, will be different, okay? So it'll be hypotenuse over opposite. Okay, double check, okay? Make sure you got the same correct names. Okay, sorry about that, right? Didn't see that it's the same, right? So all there are 6 ratios here now, and all 6 should be different, right? Double check. Opposite hypotenuse, right? We don't have anything that's opposite over hypotenuse, right? adjacent hypotenuse. Next one, hypotenuse adjacent, right? Hypotenuse over opposite. And the next one, opposite over adjacent, adjacent over opposite. So total 6. Right? So on top of SOHCAHTOA, we get 3 more. Okay? Now let's put them in a different order. The reason why I line them up like this in pairs is because of their names, right? Sine, cosine, secant, cosecant, tangent, cotangent, right? But in fact, they have another connection between them, okay? So let's line them up a little bit differently, okay? So please write it in the conclusion, sine theta, right? So right now we don't care about A or B, it's just angle in general. Theta, sine theta is opposite over hypotenuse. Let's write that down. Okay, which one is the flip over, right? Reciprocal of sine. Okay, look at the list. Which one is the flipping of sine? Have you found it? Irae, have you found the one that's the reciprocal?
Yeah.
Which one?
Cosecant.
Huh?
Cosecant.
Cosecant. Yeah, very good. Hypotenuse over opposite, right? So we'll fill that in underneath. Cosecant is hypotenuse over opposite. Okay, because it will be easier to remember if they are just flip around, right? Sine, cosecant, right? We use SOHCAHTOA to help us remember the other 3. Okay, now the next pair, we have cosine. Okay, because cosine we are familiar, right? Cosine is cot, right? Cot is adjacent over hypotenuse. So which one is the reciprocal of it? Have you found it? Samantha, can you tell me which one is the reciprocal of cosine? Do you know which one? Samantha, are you there? Secant, yeah, very good. Okay, secant is hypotenuse over adjacent, right? It's a reciprocal. Okay, next one, we have the tangent, right? TOA. So opposite over adjacent. So this one is the easiest one, right? Because they even sound the same. Cotangent, and then using the same sign, right? Just flip over. Adjacent over opposite. This is the last pair. So the conclusion will be the one I would like you to memorize, okay? The things that above is explaining why we have those names, okay? Why do we have the cosine, cosecant, cotangent? Where's the come from? But then in questions, most of the time, you just need to know the reciprocals, right? It will be easier to memorize, right? So we'll memorize the 3 pairs together, okay? So please turn on your mic again, everyone. This part we have to recite a couple times, okay? More times than other ones. Very important here. Everyone turn on your mic. Trudy? Trudy, are you there?
Yeah.
Okay, all right. So everybody, you can close your eyes. Okay, don't look at the screen. Don't look at the notes. Okay, we'll say this together. Sine, cosecant.
Sine,
cosecant.
Yeah. Okay, everybody have to say it. Okay, it will help you remember. Okay, one more time. Sine, cosecant.
Sine, cosecant.
cosecant.
Again, sine, cosecant.
Sine,
Sine,
cosecant.
cosecant.
Cosine, secant.
Cosine, secant.
Cosine, secant.
Tangent, cotangent.
and
Tangent cotangent.
Okay, let's start from beginning again. Sine, cosecant.
Sine cosecant.
Cosine, secant.
Cosine secant.
Tangent, cotangent.
Tangent cotangent.
Cotangent.
Okay, and now we're going to say the three pairs together, okay, in one breath, okay? So I'll say it first. Sine, cosecant, cosine, secant, tangent, cotangent. Okay, try.
Sine
Sine,
cosecant.
cosecant,
Cosine
cosine, secant, tangent, cotangent.
Cotangent.
Yeah, very good. Okay, one more time. Sine, cosecant, cosine, secant, tangent, cotangent.
Sine
Cosecant,
cosine
cosine, secant, tangent,
cotangent.
Okay. Now we're gonna try this. Okay, I'm going to ask you to tell me the sides. Okay, and you cannot look at your notes. I have to trust you. Okay, and then you think about it. I give you time. Beginning will be a bit harder. Okay, so for example, I will say, what is cosine? Then you will say adjacent over hypotenuse. Okay, and then maybe I'll ask you, okay, what is cotangent? Then you think about, okay, tangent, cotangent, right? Tangent is opposite over adjacent. So cotangent is the flip. So you will answer adjacent over opposite. Okay? You understand what I'm doing here? I need to know if you can connect the sides with the name. Okay? So let's start with Eric. Okay? What is secant?
Hypotenuse over adjacent.
Very good. Okay, so you think about secant, cosine secant. So cosine is adjacent over hypotenuse. Then you flip hypotenuse over adjacent. Okay, so you need to do this real quick. Okay, without looking back at the notes all the time. Otherwise, when you do homework, it will take you 5 hours. Okay, so I will help you memorize before you leave class today. Okay, so it will be easier on your homework. Okay, so let's try continue, right? Tiana, what is cosecant?
Hypotenuse over opposite.
Yeah, very good. Okay, so sine, cosecant, right? So the flipping. Next one, William, what is cotangent?
Adjacent over adjacent over opposite.
Yes, okay, flipping of tangent, right? Next one, Cindy, what is cosecant?
Hypotenuse over opposite.
Yeah, very good. Okay, and Trudy, what is secant?
Secant is hypotenuse over adjacent.
Yeah, okay. Okay, how about each one of you, okay, I'll go in order, okay? So each one of you will tell me the sides for cosecant, secant, cotangent, okay? The one that's the three new ones, okay? So cosecant is hypotenuse over opposite, okay? You say the whole name, right? So let's start with Donna.
Okay, cosecant is over hypotenuse over opposite.
Yeah.
Secant is over hypotenuse over adjacent. Cotangent is over adjacent over opposite.
You said over twice. How come? You can just say
What?
Yeah.
But
Cotangent is
cotangent is
what over what?
adjacent over hypotenuse.
Yeah, yeah. Okay, maybe I heard it wrong. Okay, I thought I heard you said cotangent over adjacent over opposite.
Oh.
Right? Yeah. Okay, so you just said cotangent is. Okay. Next one, Cindy, your turn.
Like say all of it.
Yeah, yeah. The three new ones.
Cosine is adjacent.
Cosecant.
Cosecant is hypotenuse over opposite
Mm-hmm.
secant is hypotenuse over adjacent
Which one are you saying?
secant.
Secant, okay. And then?
And cotangent is adjacent over opposite.
Yeah, very good. Okay, Eric, your turn.
Cosecant is hypotenuse over opposite.
Mm-hmm.
Secant is hypotenuse over adjacent.
Yep.
Cotangent is adjacent over opposite.
Good. Okay, Samantha?
Cosecant is hypotenuse over opposite.
Mm-hmm.
Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite.
Yeah, very good. Okay, next one, Tiana.
Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent,
Yep.
and cotangent is adjacent over opposite.
Very good. Okay, Trudy.
Cosecant is hypotenuse over opposite.
Mm-hmm.
Secant is hypotenuse over adjacent.
Yep.
Cotangent is adjacent over opposite.
Yep. William.
Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent.
Mm-hmm.
Cotangent is opposite. Wait, no, adjacent. Adjacent over opposite.
Yes. Okay, Ray.
Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite.
Okay, very good. Okay, let's take a break. Okay, and we'll start the class again at 6:30. Okay, I'll see you then. If you have questions, you can stay after.